Yeah, I started reading it last night.
Didn't you?
That's fine.
Was that right?
Yeah.
No way. I played. I played.
Yeah, I'm excited. My sleep was
Okay, so we're on page 16. We're going to start our next portion of our conics units. So we'll be starting with ellipses today. So we'll have ellipses today and tomorrow and next Monday. Hyperbolas Monday and Tuesday. But I think I want to try to push ahead, see if I can get through everything by Tuesday and then review Wednesday. Because what I would like to do is I want to be able to give the option, since spring break is next week, I want to give the option for students, if you would like, to take the quiz. The quiz is only over ellipses and hyperbolas. Either Thursday or Friday. Okay, so my plan is that for any students who want to take the quiz on Thursday, next Thursday, I'll just plan to have a room that's quiet so that students who want to take the quiz can take the quiz, and those who are prefer to take the quiz on Friday will just either do something quiet or they can work through the review sheet.
There's no test.
There's no test, right? Just quiz, 2 quizzes for this unit. If you have any questions, I will walk around and just still help students who want to get help. But just in case, you want to manage your schedule a little better, or if you're not going to be here on Friday, I want to give that option. So Thursday and Friday will both be quiet days in the classroom. Okay. All right. Any questions about that? So I'm hoping that I can kind of push ahead and get through everything by next Tuesday, so that Wednesday I can have as a review day, and then Thursday quiz day and Friday quiz day. All right, so let's look at our notes. Have you guys spent some time writing these definitions down? I guess I could also draw the, but I'm going to just have us look at the diagram that I have for you and just point these characteristics out once you guys had a chance to write these down. So ellipses are different than circles in the sense that we still have a center, but we have kind of an oval shape, right? That you kind of think of it as there's kind of 2 radius. You have a radius that's different along the horizontal than it's along the vertical. So a vertex is going to be the furthest point from the center. So if the ellipse is longer horizontally, then your vertex will be along the horizontal, will be at the endpoints along the horizontal. But if your vertex, if your ellipse is longer vertically, then your vertex will be above and below your center. And we call that the A value. The A value is the distance from the center to the vertex. And then the co-vertices are perpendicular to the vertices. It's B units away from the center. So if my vertices are along the horizontal, then my co-vertices are along the vertical. And then your co-vertex will always be shorter. That axis, that co-vertex axis will always be shorter than your vertex or your distance from vertex to vertex. So we call it the transverse axis, the distance from vertex to vertex, and then co-vertex is a conjugate axis is the distance from co-vertex to co-vertex. And the distance from the center to a co-vertex is the B value. So I guess you can kind of think of the A and B value as your quote unquote radius, but we know it's not the same radius all the way around. But it is distance from the center to a point, point on the ellipse. Now, with parabolas, remember we had a focus, right? Focus was inside the parabola. But ellipses, you're going to have two focal points, okay? And I know it's a little strange here, but the plural for focus, it's foci. It's not pronounced foci, it's pronounced foci. So I know it kind of takes time to get used to pronouncing it that way, but it's pronounced foci. The C is pronounced with an S. Okay. So foci are two fixed points along between the vertex. It's just important. It's an important point that basically builds that ellipse. And both of the focal points are C units away from the center. So if you know the A, B, and C value and the center, you can get to all the important points on the ellipse. You can A unit away from the center to the vertex, B units away from the center to the co-vertex, and C units away from the center to the focus. All right, and also we have something called eccentricity. Eccentricity is your C value divided by your A value. It measures how circular your ellipse is. So the more circular your ellipse is, the closer your eccentricity is equal to 0. So for instance, a circle is perfectly circular, so eccentricity is going to be 0. And an ellipse is going to be somewhere between 0 and 1. So the more oval, the flatter and more oval your ellipse is, the closer your eccentricity is to 1. The more circular your ellipse is, the closer it is to 0. And we can always get exact value of the eccentricity by taking the C and the A value and dividing them. Okay. And then there's also a special relationship between the A, B, and C value. And it kind of looks like Pythagorean theorem, but it's A squared minus B squared equals C squared. Okay, so if I have the A or B value or A and C value, if I have two of the values known, I can always find the third missing information by plugging into that formula. So again, it has a similar form as Pythagorean theorem, but it's A squared minus B squared equals C squared. Thank you. All right, there are two major equations that we want to be aware of. We have the horizontal major axis, and then we have the vertical major axis. So horizontal major axis is where your ellipse is longer along the horizontal. Okay, and if that's the case, then your HK is the center. Okay, very similar to your circle, but then what's underneath your ellipse equation are your A and B values, but you have to make sure you take the square root to get to the A and B values, and then it's always equal to 1. Right. So basically, whatever is larger under the, if you look at a vertical versus horizontal major axis, the way you can tell whether the orientation is either horizontal or vertical, you look to see which one has a larger value. if your larger value is under the X, that means it's going to be more, it's going to be longer along the horizontal. If your larger value is under the Y, then it's going to be along the vertical. Okay, so we always look for the larger value. And that larger value, we look to see, is it under the X or is it under the Y? Okay. All right, so I think the easiest way to kind of understand this is just to jump into the example and just start working through. Okay, and I'll continually bring up this diagram. So this is on your, this is the summary sheet that is attached to your calendar, but also have another variation. I mean, it's pretty much the same thing. It's just have a slightly different looking diagram. Okay. Okay, so looking at number 1, okay, it says graph the ellipse, state the center, vertex, co-vertex, foci, and eccentricity. So first thing, let's pull the center here. What do you think the center is for this ellipse? 3, 1, right? It's the same way that you would find center of a circle. Okay, which value is larger in the denominator? 4, okay, and the 4 is under which variable? Under the X. Okay, so that is going to tell you that your ellipse is going to look more like this. Okay, it's going to be horizontally longer. So, just so that you can have something to compare with, this is what you would expect. You expect your vertex to be to the left and to the right. You expect your co-vertex to be above and below. So I like to just draw a quick diagram, just so that I can have something visually to connect with as I'm working through my problem. Okay. All right, so I know my A value is always the larger one, but this is not A value. This is actually what? A squared. So I got to take the square root. All right, so what's the A value going to be? A is 2. Okay, so I'm going to go ahead and put that to the side. And the B value is 1. Yeah, in this case, 1 is the number where if I take the square root, I'm still going to get the same number. So my B value is 1. Okay, so I know my A value is the larger value. So I'm going to, from the center, I'm going to count to the left and to the right 2 units to get to my vertex. Okay, so start with your center, 3, 1. Okay. 2 units left, 2 units right. B value is 1, so from the center, you'll go up 1 unit, down 1 unit. From there, you should be able to create your ellipse. Go ahead and identify all the order pairs that you just plotted. Okay, there are 2 focal points. Again, this is pronounced foci with an S. We want to go through our formula to find our C value, because the C value is going to help us find that distance from one point to the next. Okay, so we have our formula, C squared equals A squared minus B squared. C squared equals 4 minus 1, so C squared equals 3. What's my C value? C squared equals 3, so therefore C equals square root of 3, yeah. Okay, if you put in the calculator, that's around like 1.7. So, I know it's kind of difficult to do, but you're going to count from your center 1.71 units to the left and to the right, and it's going to be really, really close to your vertex here. Oh, and then your focal points is always along your the same line along the vertex. So whichever direction you move to get to your vertex is also the direction that you're going to move to your focus. So your vertex, foci, and center are all lined up along the same line. Okay, so if you look, vertex, focus, center, they're all along the same line. Vertex, focus, center, all along the same line. Your focus is always along your major axis. So to indicate that I'm moving to the left and to the right, √3 units, this is the way I like to write it. I like to start with the center 3. I'm just from 3, I'm going to the right 1.7 and to the left 1.7, but I want to leave it in this radical form. So I'm going to say 3 plus or minus √3, comma 1. So all that's saying is I'm starting at 3, 1, and I'm moving to the left √3, and I'm going to the right √3, which is around like 1.7. So this is a way to indicate my two order pairs. This is really saying, 3 plus √3, comma 1, and 3 minus √3, comma 1. But if you want to merge those two order pairs into one, you can use that plus or minus to indicate, really it's just two order pairs just written as one thing. So either or, you don't write, you don't have to write both of these, but this would be the expanded version of these two, of that condensed order pairs. Okay, any questions so far? All right, eccentricity is C over A. So I'm going to take my C value, divide it by my A value. So it's going to be √3 over 2. Okay, in my calculator, I'm going to put that in. 0.86. Okay, any questions? All right, number 2. Let's start with the center. What's the center going to be? 0, -2. Okay. Look at the denominator. Which is the larger value? 25. So that is going to be related to your A value.
Vertical, right?
Yep, square root. So therefore A equals what? 5. Now look at that 25 there. It's under the Y. So is this going to be a vertical or horizontal?
Vertical.
Yeah, this is going to be a vertical major axis. Okay, so you know that your ellipse is going to look more like this. And then your focus, your foci, will be along the vertical or along the horizontal. So if I have a vertical major axis, my focus is going to be along the what? Along the vertical, yeah. So your focus is always going to be along the larger axis, the longer axis. Okay, so I'm going to fill everything in, see if you guys can try the same. The nice thing here is that the C value ends up being a whole number, so I can just count up and down without having to resort to square roots. Okay, any questions? Okay, let's do one more, and then I'd like to get started with day 2. And really, day 2 is just having to deal with completing the square and getting from general form to standard form, which you've already gotten a lot of practice with parabolas and circles, so it shouldn't feel all that different. Okay, but let's do one more, and then so if we can do, how about we do number 4? So number 4 on page 17. Have you guys tried that on your own? Make sure you're comfortable with identifying the orientation of the ellipse, the A, B, and C values. And then once you're comfortable with this, let's see if we can finish off by trying one of the completing the square problems. I'm hoping I can get through all the ellipses by tomorrow. I can spend Monday, Tuesday doing hyperbolas, and then Wednesday review, and Thursday, Friday. You can pick which day you want to take the quiz. Now, because I'm moving my focus up and down 4.5, I know I want that root 20 to impact my Y value. because the -2 is not changing. It's the -3 is the y value that I'm moving. So you can just take your center and then attach that √20 to your y value. So basically, you're taking your center and you're basically that plus or minus √20 means that you're moving up and down 4.5 to get to the focus. Okay, let's do one more. You guys can turn to page 18. I wish I provided more space to go through this process, but we'll just see what we have. So page 18, middle of the page, there's a problem in standard form. I write the standard form of the equation of ellipse. So what's different here is that it's okay to have a coefficient that's greater than other than 1. Okay, we're still gonna work with it, but we know it's not going to be the same all the way through. We can't just divide everything by 3. So we're going to have to separate the x's and y's a little more than before. Okay, but it's the same idea here. Let's work towards our standard forms position. So we're going to put the x's together, put the y's together, and then put the constant on the other side. Okay, just kind of see what happens here. So this is page 18, number 3 here. Okay, we're still going to complete the square for the x's and the y's, but that 3 does present a slight issue. So we're going to take out a GCF for just the x's, so we can get that x squared to be protected, so that we can go through or complete the square process. But it's a little bit more involved than what we saw with circles and the parabola. So what we're going to do is you're going to take out the GCF of 3, but it's only going to be for the x's. Okay, so if I take out a 3 for the x's, what am I left with? X squared plus 6x. Okay, we are going to save a space for completing the square, so go ahead and put a plus space here. Okay. Now, are the y's okay? Is there a GCF we need to take out? There isn't, so this is okay. So I'm going to go ahead and write that down, plus y squared minus 2y plus space equals -4 plus space plus space. Okay, so just like before, we're going to complete the square, but there's something additional that we got to keep track of. Okay, the first b/2 squared, what goes inside this space? Yep, 6/2 is 3, 3 squared is 9. So 9 goes here. But there's something that's a little bit different here. Even though 9 goes here, do you know what number is going to go on the other side? Well, so it's definitely not just 9. There's something impacting this 9. That 3, yep, that 9 is inside the parentheses, which is really a 27 that's sitting here. So a 27 needs to go here. So anytime there's a GCF that is pulled out to complete the square, we have to involve that GCF with that blank space value that we found. Okay. B value here is 2. Yeah, 2 over 2 is 1. 1 squared is 1. So 1 goes here and 1 goes here. Okay, multiplies to be 9, adds it to be 6. Yeah, 3 and 3, x plus 3 squared. Multiplies to be 1, adds to be -2. -1 and -1 equals. So we have -3 plus 27, which gives us what? 24. Yeah. Okay, so we complete the square, but it doesn't quite yet look exactly like our ellipse equation, right? So still a little bit off. So what do we need on the right side? We want a 1. So what can I do to force a 1 to show up on that right side? You divide by 24. So that's the additional step that we did not have to worry about before. There's going to be a denominator portion. And now this will get cleaned up to the point where we can see the A, the B value. So in order for our ellipse to show up, we are going to have to force that 1 to show up, divide everything by whatever is the constant that you see there. And then now let's reduce. Okay, so 3 over 24, this reduces to be what in the denominator? 8. Any changes here? No. Okay. Okay, which one is involved with the A value? Yeah, so root 24 will get you to your A value. Root 8 will get you to your B value. Your center will be -3, 1. Okay. Now this one is a little messier because these are not nice whole numbers. But let's hold off on this. Okay, so I feel like you guys understand the process. Can we just do one more complete the square problem? Okay, and I just want us to go through that complete the square process. And so that tomorrow we can kind of practice and kind of move on and finish off the ellipse. So let's just work on number 1. Okay, so as you guys try the problem, I'm going to work alongside you guys. All right, so now we've got to do this twice, right? We have to worry about the coefficients in front of both variables after we fill in the space. My B value is 14 here. 14 divided by 2 is 7. 7 squared is 49. 49 goes here, but we got to be aware that's more than 49 that goes in this space. We got to involve that coefficient in front. So 49 goes in the first space. On the other side, I have 196. 36 goes in the second space, but 324 shows up as the second space. Okay, complete the square, multiplies be 49, adds it be 14. That's going to be 7 and 7. Multiplies be 36, adds it to be 12. That's 6 and 6. And then negative 484 plus 196 plus 324. Okay, we're almost there. We want to force a 1 on the right side. A 1, so divide everything by. Yeah, divide everything by 36. What happens if I reduce the 49, 4 and 36? 9. Thirty-six and 4, reduce it to be a 4. Okay. And then once we're in standard form, then we can go through the process, find the A, the B, the center, the C value, and then plot and graph everything. Okay. I wanted to make sure I got a little bit ahead with completing the square. Okay, any questions? Okay, so we'll do some more practice tomorrow. We'll work on some word problems, and that way we can start hyperbolas on Monday. Okay, can we get your phones?
Nice.